Hadoop file system. And then after that, we wanted to get into the MapReduce programming model, and then see how we can do on large data the processing using MapReduce. I think that's where we were in the last class. Okay. Uh, what I want to also do as part of this is, in fact, I thought during the two, three lectures that I missed, I wanted to actually ask the students to set up things for you, but unfortunately, I couldn't actually manage to set that up. So, but then what I'm going to do is I'm going to request some 2-3 colleges we have been able to give some help in setting up the Hadoop cluster. But then what I thought was, as I was doing this, I will also let the other colleges take the help of that that thing. So I'll introduce the people who can help you with the cluster setup. There is a Bossmool stack with the HDFS that's available for download from our site, and then you can actually take help of these people in setting up a cluster for you as I was doing. Then you will be able to do the assignments also locally on your at your place. That's the easy way to set up the cluster, rather than we find a free cluster for you and you log on to the free cluster, either IIT cluster or Amazon cluster. Then we have to actually make sure that when you're working with that cluster, the cluster is on and all this stuff is available for you. The Elastic MapReduce cluster of Amazon is not free, so we won't be able to provide access to it. I can just show you. I'll show you how to use the Amazon Elastic MapReduce cluster. But each college, if it wants to make use of it, they can make use of it in whatever way they want. Okay. But some of the assignments that I'm going to give you will be more easily done if you actually have the stack installed in terms of what I'll be giving now. Okay. For you to get the help, I just thought I'll introduce the team that will help me with this, and then they can further take whatever help that's needed for you from the lab, and they also will do some tutorial sessions if required, additional tutorial sessions. Let me just call them and see if Balaji, can you just come along with Abhinay and then Madhu? Yeah. So before they join, what I'll do is I will sort of now spend a little time today actually. Try to now give you an idea of Hadoop file system, and also how MapReduce programs run on the Hadoop. We'll give the theory part of it today. And then if possible, we'll also show you how to use a cluster. But before that, I suggest that I think I'm just asking the others to join me actually. I think you should come closer, okay, so that they can see you. I think this is an online course, so this will go live to the other people, right? I don't know, this is the only window that I think you can come more closer. Yeah, this is Abhinay. Yeah. I think Balaji is on this side. I think Balaji is interacting. Balaji is from CDAC. Okay. Balaji, can you just no, maybe you just can move into the other one. Okay. I think this is Balaji. He is from CDAC. Hope all of you are able to see him actually. He will help you. He is from CDAC Delhi, and then he is in the lab, and then he is the one who will help. There's also one more CDAC person who is going to also help you. That is Vikram by name. Vikram will also help you. Both these are CDAC Delhi employees. Vikram, come here. Okay. I will share. I will share. I think I think you have to come here. Then you will be able to. They will be able to see you. I think, as far as I can see. This is Vikram. He also comes from CDAC Delhi. Both these are CDAC employees, and they are part of the Bossmool operating system, and they are also part of this project on how to actually make Bossmool for big data systems. So they're actually working on improving the Hadoop file system and MapReduce performance using the Bossmool stack, which the government wants to deploy in a large number of data centers, and the private organizations also want to make use of this operating system. They're working in the lab now along with CDAC. These two people will be your primary contact, and they will sort of help you with setting up the Bosmool Hadoop cluster for you. I think they already helped the Vijayanagaram college, I think, yeah. And so now the Kakinada college also, and then the other colleges can also take help from these two people. They will their email address and the phone numbers. I'll share it with you. Is the link available now? The link is set up now. Okay, the link is set up from where you should be able to download and set up the whole cluster for yourself locally in your campus. Okay, so take help from these two people. I have my MS student Abhinay, who also works with this team. Abhinay is the one who is helping both Balaji and Vikram in terms of doing this big data research. He actually works on for his MS research. He works on integrating the storage. He works on integrating the storage component to the cloud. Actually, he works on how to integrate a local file system with the cloud storage system. That's was his MS research work. I also have one more MS student who is working on big data processing. He actually works on graph processing systems. His name is Srikant Padala. I'm not sure whether he is available right now. He'll also help you people. Is he there? Maybe you can just call him. Okay. Srikant will also help. Will help this group in terms of trying to help them do some assignments as part of it. I think the local cluster is being managed by Srikant. IIT Madras Yahoo Grid cluster is managed by both Abhinay and Srikant. So Srikant will also help this team with whatever help that is needed. Okay. I also have with me Madhu, who is actually the project advisor. Yeah, I think you can come this side. Okay. Madhu is the project advisor in the lab. Actually, he looks after. He's earlier actually the additional director of CDAC Chennai. Okay, he was working earlier as an additional director, right? Or joint director? Associate director of CDAC Chennai. He also was in various capacities. I think Professor Murthy knows him. I think he traveled earlier for the MOU signing of Bosmool to Jntuk Kakinada. He was the one who was instrumental in signing up between Jntuk Kakinada and IIT Madras CDAC, the MOU on Bosmool operating system. So Madhu is the overall in charge for this operation. So I think Madhu will sort of coordinate between the various colleges and these people here to help you actually take this forward. As is doing this course, whatever other logistic support that is needed will be provided Madhu. Okay. I'm going to ask Madhu to talk to you one of these days. All these four people will talk to you in one separate session. I think Srikant is also here now. So Srikant is the other student actually. Srikant Padala. Okay. Yeah, I think come sit down. Yeah. Srikant is a very young, dynamic guy. So I know, right, with a lot of energy. So he's the other one who is working on the big data processing. I think his work largely is involved on multi-tenancy in graph processing systems. He worked also on Hadoop systems, and he knows probably he claims that he knows ins and outs of Hadoop systems, right? So you can actually test him out by actually throwing a lot of challenging questions, problems to him. You can figure out whether how much he really. But I think he enjoys throwing some challenges at him. Okay, so he's the other person. He's locally helps with the cluster, so along with Abhinay. So I'll also request his help. I think. We are now live going to a number of colleges, so they're going to send you a lot of emails to you asking a lot of questions. Okay, Srikant? Yeah, sure. Right, yeah. So I think I'll get back to you people later. So when it's needed, some more help is needed, we'll plan and then give them. Okay? Yeah. Thank you. Thank you. Yeah. Okay. Yeah. Yeah. So I guess then that's I think you can give me in a sheet of paper all your email addresses, which I can share it with them. Just write down the email address of Madhu and the three of you, so that I can share it with them. Okay. So that's I think is the logistic support that we are planning. I'm also told that next 1 month is what we have. In between, I'm also planning to travel back again to US. So I think uh, I'll see how I will probably, some part of the lectures may have to be given when I'm in the US, but the time zone problems might come in. Okay. Let me figure out. I think as I'm doing this, maybe let me try to see how much I can do and how much I can sort of finish things. But then I actually take the support of these people. In terms of now, if I'm not around, I probably will ask one of these people to interact with you, and then all of them are actually hands-on people, and they've been working on this big data processing for a while, so they should be suddenly be able to set right anything or any questions that you may have. Okay, right. That's I think is the sort of the support that we will take as we go forward. Okay. Now coming back to the lecture, what we've been doing in the last class is looking at the Hadoop file system and the Hadoop architecture. Okay, uh, one difficulty for me is I still have to figure out. I'm not able to actually use the whiteboard, because I think if I use the whiteboard, I think it is not completely visible for people. So I will try to actually see if I can, I will start using some slides, okay, which and I'm actually I'll start using couple of slides to actually start discussing, how the architecture looks like. Okay, I think this is the first slide. That let me share the desktop so that you have some. Start sharing the desktop. Yeah. So I think, is this slide visible now? I actually can't go into the, is the slide visible? Is the slide visible? The slide that I'm projecting, is that visible? Can you just reply in the chat? Yeah, yes, okay. So all the people are able to see. So I'll use this one, okay. So and then sort of explain, everything, okay, with this one slide, and then sort of get to the point where the HDF fits in, and then how the whole MapReduce stuff actually works, okay. As we were telling the previous time, you can see that in this slide, I will start pointing out, this is actually the map function. So given a map function, it takes as an input a key and a value pair. Okay, the output of it is actually a key value pair list. Okay, a list of key value pairs. As you can see, the reduce actually takes each key K2, which can be produced anywhere in the distributed system, takes this list and reduces it to one final key value pair, which will be stored on the Hadoop file system. Okay, this is a top level view of the MapReduce programming model. Okay, now in terms of these key value pairs, where these key value pairs are stored, that's where the data blocks on the HDFS Hadoop file system comes into picture. So what do we do now? First take the data, then as you give the data, it gets distributed on these multiple nodes. Okay, on these multiple nodes of distributed system. Okay, as you can see here, if there are n nodes in your distributed system, all these initial data will get distributed to n nodes. Okay, now the HDFS architecture is such that we also have the link where the stack is there. So can you just put that one also? Okay. Yeah, so as you can see, the architecture here, the essential architecture here is going to be that this part of it is actually managed by HDFS. So how is that managed? So your data, initially where your data is part of a name node here. Okay, so we have as an architecture, every cluster has one name node. Okay, only one name node. This is one of the limitations of HDFS systems. Okay, for even for a large cluster like 35,000 nodes, we have only one name node. They're trying to actually figure out how this limitation can be avoided. So further redesigns of HDFS, as I understand, are in progress. But then a single name node is a bottleneck, but then that's how the HDFS file system operates. What does the name node does? Name node actually stores the metadata information of the files. Okay, the metadata information of the files are stored. Unfortunately, this is the only slide that I have for HDFS. Okay, let me still see if I can go to the board one more time and see if the board will give us a little a little better way of explaining this. I'll try one more time with the board, stop the desktop sharing, okay, and then see if I actually maximize that one, then you will have problems, because then I will not be able to come into the I've actually stopped the desktop sharing, and I will sort of use my board here, which is here, to explain the HDFS architecture, okay, and then see if we somehow will manage today with the board. If this happens, then I will be in a better position, because then I can actually go deeper in terms of explaining things for you. Okay, right? So the architecture of the Hadoop is something like this. You have actually the name node here. Okay, this is the name node. Please keep listening to me and then look at the board. Then it becomes easy for you. Okay, there is a name node here. Okay, and then there is okay, there are a set of data nodes here. Each of these are actually called the data nodes. This is where the data, actual file data, is actually stored in each of these data nodes. Okay, there are n number of data nodes. Okay, these are the data node, and this is the name node. For each cluster, you have only one name node. Okay, now the name node will have the metadata information for each of the files. This is basically stored as an image. This is actually stored in memory. All the name node details, metadata, is in memory. Okay, so they actually are stored in terms of what are the, this gives the file name and the data blocks, where are all the data nodes on which the blocks are stored, what is the replication factor for each of the files. Okay, now based on the replication factor, you have to make sure that the file content is replicated on enough data nodes. Okay, the way Hadoop file system manages it is by replication. Okay, so you actually replicate the contents of the file on multiple data nodes, and that's how the reliability of the, even if one node is down, one data node is down, you still will be able to access your data from other data nodes. Okay, this is called actually a primary name node. They actually checkpoint all the information onto the disk into a separate file, Unix file. Okay, and then it is stored on a Unix file. You also have a secondary name node, which as a backup to the primary name node, you also have a secondary name node as part of the design. Okay, but then the details are mainly available in the primary name node. So a client actually first consults the name node. Okay, the protocol between the name node and the data nodes is by a heartbeat algorithm. Okay, so heartbeat algorithm means there is every data node has an outward beat and an inward beat. Similarly, the name node also have an outward beat and an inward beat with each of the data nodes. Okay, so what does that mean? That means the name node will send a message to the data node, receives a message from the data node. So each of them will be having a heartbeat protocol that is accept in the first instance when the data node actually will have a handshake with the name node. The first time the data node starts talking to the name node, there will be a handshake. With that handshake, the name node accepts the data node as into the cluster. Okay, that depends on what version and what is the file system details that this data node is having. Based on that, the name node is includes the data node into the cluster. Okay. Now, once the data node gets included into the name as part of the name node, for integrity purposes, if we are actually storing a different kind of a file system, you will not be able to become part of the name node cluster. Okay, so it checks for the versions and other things so that the file system is to maintain the integrity of the file system. Once the name node accepts a data node into the cluster, after that the communication between the data node and the name node is only by this heartbeat algorithm. That means every so many time intervals, the name node sends a message and receives a message from the data node. All the information that is needed as part of the protocol is embedded into this heartbeat messages. Okay. For example, if there are various things, in terms of how the data node works with the name node. For example, if the name node doesn't get any heartbeat message from a data node for about 30 minutes, I think it's 15 minutes. It's a tunable parameter. If it doesn't receive any information from the data node for about 15 minutes, it considers that the data node is down, and then it starts making attempts to replicate all the blocks that are there on that data node onto other data nodes. Okay, it replicates that data into the other data nodes. Okay, it suspects that the data node is down. Okay, so each time, every 3 seconds, okay, the data node heartbeats with the name node every 3 seconds, giving information about the blocks that it is responsible for, how much percentage of disk is available with it, and lots of other information about the data node health and quality are actually given to the name node. Name node actually uses this information to decide how the block should be split and then should be put onto these various blocks. Okay. Right now, I will not go into consistency issues, what happens with consistency of the Hadoop file system, because that requires more deeper explanation of the distributed protocols and how distributed protocols work from the consistency point of view. Okay, that is slightly out of scope at this point of time. I'll see if I would like to introduce that at a little later point by teaching a little bit more of the fundamentals of what exactly is the consistency problem here. Okay, for example, if writes are made onto replicas, then how they can be made to be consistent. Okay, actually they will not be completely consistent. What is maintained is an eventual consistency in the system, but for you to understand what is eventual consistency, it will take a lot of effort from my side. Explain what is consistency protocols and how that is actually maintained as part of this. Okay, we'll keep right now out of the scope. Okay, now what is the stuff that the client will do with the HDFS system? This is the basic architecture of the HDFS system. Okay, this is completely different from an architecture that you see in terms of network file system, because each of these data blocks are actually 64 MB blocks, file blocks. Okay, or a multiple of 64 MB file blocks. Okay, so what we are talking about is each of these blocks, data nodes storing 64 are larger than the multiples of these 64 MB blocks as part of the data nodes here. Okay, right. Why 64 MB? There's reasons for actually design of these sizes. We will not get into that at this point of time. But then it can also be a multiple of that. Okay. Remember, these are regular Unix files. Okay. There are ways in which you can figure out, if you go into HDFS, you can find out there will be two regular Unix files. One will be for 64 MB block size, and the other will be about the metadata on this block. For example, what are the checksums and all. For example, each one of this will be two files. File 1 will be just the data. File 2 will be the metadata for this block. Okay, and then this will be the actual data that will be stored in file 1. So every one of them underneath will be a Unix file. So this is built on top of the Unix file system. So every node will be running a Unix file system, and on top of it the metadata is actually, if the name node wants the metadata, then it's actually in file 2, otherwise it is in file 1. Okay, so you will have corresponding IDs here, which are where the data nodes are, those IDs with the name node. So when a client actually asks for a particular file, for example, a client wants to get a file, HDFS file, then you actually go here and then pick the, from the name node, pick the data node. Name node gives you the best available data node from which you can read the file. After that, the client will start interacting with the name node to directly get the data from the available disk. Okay, that's the yeah. Okay. Hope everything is fine up to this point. Okay. Are there any questions on this at this point? Suppose client is requesting 1 TB to store to HDFS. We'd like to know when it will be divided into blocks, given that the name node does not have 1 TB disk. No, actually that's not correct. What the name node, given a file, if you ask for the file, it actually gives you the data nodes where these blocks are going to be placed, and after that the blocks are actually stored on those nodes. So given a file of 1 TB, it will be divided into 64 MB blocks. Okay, and each 64 MB block will be placed on one node, one in the cluster. So how many number of data blocks that are needed, data nodes are needed, that many data nodes will be supplied by the name node, and your data will be stored. For example, let us say there are 3 data nodes, and the name node then splits this 1 terabyte of data into these nodes and then stores all the data in these data nodes. So this is the responsibility of the name node to split it. Okay. When it will be divided in the beginning itself. So if you actually if you are giving if you are actually asking for a file, you are writing a file into HDFS. Okay, that's the time actually the client is writing the file. So a new block, each time it has written a 64 MB chunk, then that will be, then it requires a new block to be written. That's the time it is going to go and then ask the name node for a new block. When it asks for a new block, it actually allocates. Every 64 MB block is allocated by the name node. Each time it is required by the client, it allocates. While allocating, it looks at the data usage, all those things, how many nodes are available, what is the best place to place this data node, data block. It gives that data, and you will start writing the information on that data block. Okay, is that clear? You have a large file, you're copying from a local file into the HDFS. Each time one block, 64 MB block is written, the system needs the next 64 MB block, it will be allocated. So as you are copying, as it is copying the 64 MB blocks for the file, each time a block has been written, the next block will be allocated depending on which is the best node to be placing that block in. Okay, is that clear? Okay, so the name node, the HDFS file system, and the name node will be responsible for distributing the file content into the different data nodes of the file, into data nodes of the cluster. Okay, so given a large file, the name node decides. It has an algorithm, and then it has a load balancing algorithm which is part of the name node. It makes sure that data is evenly distributed across a large cluster. For example, if I have a 1200 node cluster, how do I actually split these data nodes? And then, one of the recent problems that I've seen a lot of people reporting to me, it's an interesting problem. Okay, uh, this is actually with the production clusters people are using. The production cluster looks like become quite unevenly balanced after a period of time. Apparently, the way the data is placed becomes unevenly balanced, and the performance of the MapReduce jobs apparently comes down drastically. This seems to be an interesting research problem for somebody to look at. If somebody is trying to work on a research problem, this is a very good research problem. For example, you can set up a cluster and you can actually make it as a production cluster, and over a period of time, the way this data is split and then put on the production cluster, the fragmented data blocks on different clusters makes the MapReduce performance really come down, drastically comes down. Apparently, this is one of the critical problems that a lot of people have actually reported to us. Actually, this is one of the problems we are also looking at. But then it's interesting for multiple people to look at a problem like this and see what solutions are possible as part of the solution, as part of the research that one can think of. Okay, but then it's a deep research. For example, you need to understand the Hadoop code here, and then how the Hadoop name node uses its balancer, and then how it actually looks at all the information from the data node in this heartbeat algorithm. Whether you want to actually include more data as part of the heartbeat algorithm, then you have to go inside and then change the thing. Okay, if there is a 130 MB data, if we place it in two data nodes, then the remaining 2 MB is placed in the other block, which leads to a decrease in the performance. Can we increase the block size? Uh, just think of this always can happen, right? So the question is, you will either use 64 MB or multiples of 64 MB. Okay, please understand this is actually a big data problem. Okay, so if you are using only 2 MB data and using HDFS file, it will create one block for you which is of 64 MB, and it will give it to you. Okay, you might only end up storing only 2 MB data into it. It doesn't really matter, but then it's going to be always multiples. No, and your understanding that this will suddenly lead to decrease in the performance is not correct. Okay. There is other factors to the performance, including how the maps are working, how the maps and reducers are working. It's a whole lot of complex part in terms of how this whole thing works. So this data split is one part. Okay, um, if you have real large files, you can suddenly increase this to 128 MB. Okay, instead of 64, make 128. Okay, that's what people do. Sometimes if they see that the files are really large, and then instead of 64, they want to actually tune it to 128 MB, they can do it. But then suddenly 2 MB and all that, people don't tune it because it doesn't make sense. We're talking about big data, terabytes of data here, petabytes of data for processing, and this doesn't really make sense for you in terms of trying to see, oh, one more block is needed. Yes, if one more block is needed because you have 130 MB data, you want. That's always will be the case. Okay, some files will be of some size, and then so that will necessarily require some blocks are not completely utilized. That won't be an issue. Okay, hope that's clear. Any other questions? Yeah, okay. So see, what you should understand here is HDFS came afterward. It's actually the first system that came into the Google file system. Okay, MapReduce got developed inside Google mainly because they had this petabytes of web data that they're crawling and they're trying to index. So what they're typically doing is the word count, which I told you, the keywords, number of keywords, which they are trying to actually find out from the web pages so that they can index the web pages. Since they were doing that kind of problem with commodity clusters, they just buy the servers and then augmented the servers as large clusters and wanted to do the programming on these large clusters. This MapReduce actually came because of that reason. Okay, right? So this is part of this is the basic architecture of the Hadoop file system. One key aspect of the Hadoop file system is the replication. Okay, now given a block, it's not only stored here, this block is replicated. You can specify the replication factor for the name node. Okay, for example, as part of the file creation metadata, you can specify what is the replication factor for the file. If you specify 3, for example, this data block will be replicated on 3 other data nodes. Okay, that's basically will be done by the name node. It will actually ensure that there are 3 other data nodes that are replicating this particular data into the other places. Okay, for example, assume I have a 3 replication. I will say now these are the 3 replicas. These are 3 data nodes for one data. These 3 replicas will be available. Okay. Now there will be a pipeline. There is further further architectural issues here. Normally, any writes done into one block, they are lazily propagated into the other blocks by actually setting up a pipeline. Okay, so whatever is written onto the first data block is pipelined to the second data node and the third data node. So they are actually propagated. Okay, this is the write pipeline. Okay. I'll not go deeper on these issues because that's will take us into a different level. I think there was another question from 48. Was data node maintains the metadata? See, there are two metadatas. The file metadata is with the name node. Okay. So which means that all the metadata relating to a particular Hadoop file is with the name node. That is in memory. There is a corresponding IMage file for that particular IMage data block for this, which gives the information about the data nodes and where the blocks are actually placed and what is the replication factor. All this information, metadata information about the file is available in the name node. If you come to the data node, there is a 64 MB block. Okay. Now, what is the checksum for this MB block and other related information that are needed for accessing this data is available in the data blocks metadata. So there are two files here. This is about the 64 MB block. The metadata relating to that 64 MB is available in the data node. Okay, there are two separate Unix files there, actual data and the metadata about the block. So when the client is reading, it reads for the data of this metadata because it needs to verify whether whatever data it is getting is correct or not. So this checksum padding, all that information is available as part of the metadata. So the client first reads the data and then starts reading the actual data. Okay, is that clear? Jntuk 48, is that clear? Okay, yeah, okay. So any other questions on this? Okay, so we take it that you now understand what is the Hadoop file system basic architecture. Okay, we are not doing the hands-on on HDFS now. We will do it in the next class, the HDFS hands-on. Okay, first I'll finish all the architectural issues, all the theory part that is required. Then I'll get on to the hands-on, show you what exactly happens with when you create a Hadoop file system, set up your Hadoop file system. Okay. Meanwhile, I will make sure that you have your clusters up and running then as I'm doing it here, you should be able to do it on your clusters as well as part of the course. Okay. Yes. What is the use of data replication? The data replication is required for reliability purpose. For example, what happens if this node is down? Then the data is lost, right? So you have to ensure that the reliability of the data, so that the data is always available. The file system reliability is ensured by using the data replication. Okay, right? Yeah. Any other questions on the Hadoop file system? I take it now that you know the Hadoop file system. Okay, Hadoop file system basic understanding is there. I go back to my slide and then show you okay, what I was trying to discuss in the previous slide. Okay, right. Is the slide visible? Is the slide visible? Is the slide visible? No. I've shared the desktop. Hello? Oh, so is it visible now? Okay, yeah. So, okay. So let me then go back here. Okay. So given this part should be clear now. Okay. This part of the architecture should be clear. This part of the architecture is what the HDFS part that we have seen earlier. Okay. Now this is the file data. This is the HDFS file data, and that data is split into the name nodes. Data nodes of the cluster. So these are the data blocks of the HDFS. They are actually on multiple nodes of your distributed systems. Okay. Now, how does the map and the reduce work on top of this HDFS? Okay. Now, what do you do for doing the big data processing? First, given this data, you make it into an HDFS file. That means the data blocks will be split into this HDFS blocks. Okay. So they can be node 1 here, node 2, node 3, node m, node n, okay, up to n nodes. You can split all this data into these data blocks. Okay. Now look at the no, this is created. First you have created this data blocks on the HDFS. So you've created this part. Okay. Now what you have here is the map and the reduce functions, as we were seeing last time. The map, what is the map supposed to do? Map is supposed to do the key, each key it takes, and it processes and then emits another key value pairs. Now look at here. So there is going to be maps running on each of these blocks that were split. For a minute, assume that the maps are also running on the same node where the data is placed, but this need not be the case. This depends upon where the map functions can be run. It depends on how the map functions can be picked up and run on these data nodes. But suddenly the scheduler, Hadoop scheduler, we make sure that the maps are actually run very close to the data node, so that the data transfer, picking the data transfer times are actually reduced. For the time being, assume that the map functions are actually executed on the same data blocks, okay, where the data nodes, where the data is actually placed. Now, what is the idea of this? Now, as many maps as required will be running here. This is where it becomes parallel. The map execution becomes the parallel. So what you will write now in the MapReduce programming, you will write this map functions. Okay. You will extend mapper blah 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 thing. When we see the actual Java program, you will know that how to write this map function. This will be the predefined Hadoop libraries from which you are going to extend the mapper function and then fill up what your map should be doing. In the word count example, what the mapper does, for example, for a minute assume that this is a 1000-page book in which we are counting the how many times Janikiram name actually occurred. Okay, now what do you do with this 1000 pages? The HDFS will split this into 64 pages each. So there will be so many blocks as of 64 pages. Each block will be of 64 page size. That's just for analogy I'm telling. Okay, it will be 64 MB. So I'm just taking this as a 64 page. So first data node will have the first 64 pages. The second data node will have next 64 pages, like that. This 1000-page one will be divided across the required number of data nodes. Okay. Now what is the mapper supposed to do? It is supposed to, the line number becomes the key here. For example, first line, what will be the value? Value will be the text in the first line. So each page, there will be a map which will start reading one key after the other key. That means one line after the other line. Okay. In each line, it will find out if what is the keyword. In this particular case, I am telling one keyword, but there could be n number of keywords you can specify. Okay. Each page can have Janakiram, IIT Madras, okay, Jntuk Kakinada, no, lots of Andhra Pradesh. Okay, there can be so many keywords. So now what does the mapper does? Mapper now gives, for example, Janakiram, and then if it found on the first line a reference to that, it will give. For example, 2 times it found Janakiram 2 will be the output from this mapper. Like that, it will start saying Jntuk Kakinada, okay, 3 times, IIT Madras 5 value. Okay, so this actually keeps, each map will start producing the output. Okay, as it is processing the 64 pages, it produces its output, which will be these key value pairs that are given here. Okay, right. So all these key value pairs are in memory. As this is getting executed, the mapper starts writing into the memory. Okay, if the memory is full, then it will spill over and it will write it onto the disk, the map output. Okay, but then this is in memory. Whatever is supposed to be producing the map output is here. Okay, now once the mappers have started executing and started producing these values here, give me a minute. I'll just take some water and just come back. Okay. Go. Yeah. Okay. It's open. I'll open. Check. Thank you. Yeah. So what each one of them will produce is this key value pairs. Now imagine all words relating to Janakiram can go to only one reducer. For example, if you look at here, each user has to take the output from all these maps and finally produce the required output. For example, first map could have produced Janakiram occurred 2 times in the first page, and second mapper would have said it occurred some 20 times, like that. Now what should happen? All the output of these mappers have to be sorted. For example, all words relating to Janakiram can go to only one reducer. If it goes to multiple reducers, the it goes to multiple reducers, then it will be correct, right? So what you will have here is a shuffle and a sort phase. That means Janakiram keyword produced at multiple by multiple maps all have to be shuffled sorted and brought to one reducer. Okay, so this is the most important thing that actually the MapReduce programming model does for you. There's middleware here, generic middleware sitting here, which you don't even know what, that this is what it is doing. You will write your mapper and the reducer. So what does this know? How does the mappers and reducers connected? All the output coming out of the mappers is sorted, shuffled, and then sent to one reducer. If they, for example, everything relating to JNTU Kakinada, let us say how many times it occurred, goes to this one reducer here, okay, and Janikram goes to this reducer. Then you have to shuffle, sort, and then send the output, okay, those key values into this reducer here, and the final output is actually written to the HDFS file. The final output is an HDFS file. Okay, the reducer's output is written to an HDFS file. But the map output is not written to a HDFS file. The map output is actually in memory here. This part is in memory. Okay, you should understand these nitty-gritties, because as you are executing it, the most important part is this shuffle and sort phase. Okay, is that clear? Is the shuffle and sort clear now? Are there any questions on the shuffle and the sort phase? I'll go a little deeper on this, okay, and then show you why the MapReduce becomes interesting and what are the problems with MapReduce, okay, and then how one can think of the whole MapReduce, and then what is the way to understand this MapReduce programming model along with HDFS, okay. Is this clear? Or any questions? Okay, so there are no questions, we'll move forward. So you should understand here the input, the big data file is an HDFS file. The distributed data nodes on which the maps have actually started executing, and then they started producing the output as key value pairs. I have a question here. Why should the maps and the reducers should work only on key value pairs? What is the no? Um, what is the big thing about actually keeping this whole thing as a key value pair? Why map is taking only a key value pair, and why reduce is taking as input only a key value pair? Why not anything general? Any answers? Functional programming that is suitable for distributed systems. Why? Why is that suitable? What is it makes it suitable for distributed systems? Serializability, that's not correct. Makes the output as input for other function. That seems to be making some sense. But why is this so? Why should it be key? Yes, that I think this Vijayanagaram answer is the correct. Okay, it is not the shuffle phase. Yeah, it is not the shuffle alone. It's actually the shuffle and the sort. For sorting this, you need the keys. Okay, that's why the whole thing works as on a key value pair. Okay. Now, what is the middleware doing? The maps are throwing the keys and values as an output. So the whole MapReduce programming model works in the key space, because now look at this key space here. What you can say, let us say I'm finding out all English words, keywords. Now what will I say? all words. This reducer is responsible for all words from A to, let us say, A to F. Okay. Then the next one is responsible from G to some no literal. Okay. So all keywords between A to F will come to this reducer. Okay. Now the key space can be distributed. Key space, using the key space you can sort, shuffle and distribute across these reducers. That's the reason why the MapReduce programming model is working with a key input and a key output. Okay, that without that keys you won't be able to sort it and send to. That's the key thing here. Okay, that's the understanding that you should get. Okay, my next question is, what kind of no what makes this not so generic? Okay, what will no what will why is this not a very generic way of writing your programming? Yes, I think only data parallel programs is correct, but then I'm actually looking at the key value pairs. Why is the key value pairs may not be a generic way of writing your program? See, for example, if you looked at my slide there, okay, uh, look at this here. My pages don't have any keys. I have actually forced a key on the page saying that the line number is the key. Okay, right? So for this programming model to be successful, you have to actually have a key value as an input. So you have to, your input should be made into a key space. Okay. Of course, the other thing is a data parallel, because the maps cannot communicate with each other. So, whatever output of the map, then you have to just, get that, shuffle it, sort it, and then send it. Okay. The other very interesting problem will be, if you want to redo this for some reason. For example, let us say I give you this data and you have to do a k-means clustering. You have to cluster this data into groups. Okay. Then you do one level of processing. Then you say, look, I don't have the right grouping now. I'll just go back and redo this. If you want to redo this again, then you will have a problem, because you have written this to the HDFS file. Again, you have to start another map job again here, which means that again it has loaded and then you have to write another map job. So if there's an iteration here also, then you will get into trouble as far as the MapReduce programming is concerned. Okay, right? I will go a little, how much time do I have? I'm actually now, I think I have a meeting in another few minutes. Can I take a few more minutes? Is that okay if I take, maybe another 5-10 minutes more? Okay, yeah, that's fine. So then let me go ahead and then look at what is the way this whole thing is going to work now. Okay, how the whole story becomes more live. Okay, so for doing your big data processing, what you're going to do is first create your HDFS file. Okay, write your Java program, map program, and the reduce program. You will specify your Java map program and Java reduce program. Okay, so create your HDFS file. For example, a large data file that you have. For example, you want to do the word count Hadoop processing, big data processing on large file. Okay, you create a large file, some junk file, doesn't matter, any file that you have. Then you will basically create that as an HDFS file. Then you are going to write your mapper as a Java program and reducer as a Java program and supply this to this HDFS. Now what does the HDFS does? It actually chooses the there is going to be, when a job is supplied, there is a job tracker. What does the job tracker does now? This will go a little deeper in the next class. I'm just giving you some idea what the whole process is going to be. Okay, there is going to be a job tracker. What is the job of job tracker? Job tracker now fixes enough nodes on which the maps can be started. Okay. Now it picks up enough number of nodes in the cluster where the maps can be started. Generally, it picks up the nodes where the data blocks are there. If that is not possible, it will start the mapper program at some data node that is very close from where this can be picked up, okay, easily or with less latencies. Now, should it also start the reducers immediately? The job tracker should fix the mappers and the reducers and start them immediately at the same time. Will that make sense? My MapReduce program on a large data. Why? Why will it not make sense? Why will it not make sense? See, I'm curious. When okay, output of map, some keys of the last mappers may be needed by the reducer. Okay, so what? Anyway, then when the map finishes, that will come to the reducer. Is input to reducer. See, when people are answering me here, I'm curious. Is the is this coming from the one listener or from the set of students who are listening to me? Is it possible for me to get one college live for me? Can one college publish its live feed? I want to interact with the students. I want to interact live with one college with its students. Is it possible for me? Any college here? Can it publish its live feed to me? Yes, okay. I think this is yeah, is this the college I'm seeing? Is this the college?
Yes, sir.
Yeah, okay. Can I have one student there with me? Can a student identify himself with for me? I think who is the first, that blue I think I see a blue chili girl. What is her name? What's her name? Monica. Huh? What's her name? Monica. Monica. Okay. So, Monica, are you able to hear me?
Yes, sir.
Are you following what I'm teaching you?
Yes, sir.
Are you following what I'm teaching you? Okay, I have a question for you. Okay. Why will it not make sense to start the reducer immediately? Maps and reducers, they should not be started at the same time. Yeah.
Yes.
Should the maps and reducers be started at the same time?
No, sir.
Why?
Map. First map will be processed.
Okay. And then somewhere reducer has to start. Now, why starting in the beginning doesn't make sense? Is there any other student who would like to answer that question in your class?
The output of map is given into the.
Who is the other student who is answering this?
Rajshekar, sir.
Rajshekar. Okay.
Yes, sir.
Can I see you, Rajshekar? Yeah, sit down. I think you're not sitting. Yeah. You're still not visible to me. Okay. Yeah, tell me now what's the answer?
Sir, output of mapper is given to input to the reducer, sir.
Yeah, so it doesn't make sense for you to. So when will you start now? After 10% of the maps finished? Huh?
Yes, sir. After completing of mapper, we'll start reducer, sir. We'll start
So what is
reducer
the
code.
point then? See, that won't make sense. Starting the reducer after all maps are finished will not be useful. Will not be the correct thing. Because then the reducer can also work as the output is coming in. You can start the reducers also can parallelly work, right? Right?
Sir,
Yes or
can
no?
ask, there will be only one reducer, sir.
There can be multiple reducers.
Oh, one reducer, sir.
No, no. Let us say you have multiple reducers. Where will it make sense to have only one reducer?
It depends.
Hmm?
Repeat it, sir.
Where will it make sense to have only one reducer? You want to have only one reducer?
Yes, sir.
Why? Why can't I have multiple reducers?
Yes, sir.
Anybody else in your class would like to answer me? See, understand what I'm asking as a question. It is not necessary if one answer is I will start after all the maps finish only I start reducer. That is not correct. Okay?
Reducer code for,
I can
doing the
okay, think about it. What I'll do is next class I will show you what makes sense here. One of the key things is at what level will I set reducer and why that is important in the MapReduce programming model. Okay? There are lots of nice, interesting problems around understanding maps and reducers and how they work. Okay, we will see that in the next class. But at least I'm happy that some students are listening. Otherwise, I'm getting concerned whether any is listening to me or there are only some couple of faculty sitting and responding to me. Okay, I'm happy.